Organized spectacles of light that decorates the skies of the poles, the aurora borealis and the aurora austral, captivate the imagination of all who witness them. These natural phenomena are not only beautiful but also rich in science and mystery. Today, we dive into the fascinating world of auroras, discovering their similarities, differences, and exploring the rare phenomenon of their appearance outside the poles. Prepare for a luminous journey through the science behind these wonders of nature. Auroras, whether boreal in the north or austral in the south, occur when energetic particles from the sun collide with Earth's magnetic field. This interaction energizes oxygen and nitrogen particles in our atmosphere, releasing light and creating beautiful curtains of color that light up the polar skies. Differences between aurora boreal and aurora austral. Although similar in process, the aurora borealis and austral mainly differ in location and frequency. The aurora borealis is seen in the skies of the northern hemisphere, while the austral shines in the southern hemisphere. Due to the distribution of land masses of oceans, the aurora borealis is often more accessible and observed by more people, while the austral occur in more remote and less inhabited areas, such as Antarctica, is witnessed by few. Aurora's phenomena, normally confined to the poles, occasionally offer a spectacle further south of north, as occurred during the remarkable geomagnetic storm of May 10, 2024. This event exemplifies how auroras can surprise and delight observers far beyond the polar regions. Auroras, typically confined to the poles, can sometimes be seen at much lower latitudes. This was dramatically illustrated during the notable geomagnetic storm of May 10, 2024, which allowed auroras to be observed in places distant as California and Florida in the United States, and Spain and Italy in Europe. The storm in May 2024 was triggered by exceptionally powerful coronal mass ejection (CME) from the Sun, much more intense than any observed in the past 2 decades. What made this CME notable was not just its magnitude, but also its speed, which exceeded 3,000 kilometers per second, nearly double to the speed of CMEs that caused the last significant storm in 2004. This high speed intensified the impact when its Earth's magnetosphere causing much more severe magnetic disturbances than usually recorded. Comparing this storm to that of 2004, we see significant differences in intensity and range. While the 2004 storm was powerful, its influence was predominantly observed at the poles and high latitudes. In contrast, the 2024 storm, due to its extremely fast and potent CME, expanded the aurora zone to latitudes where such phenomena are rare. This trait not only surprised scientists, but also provide a rare opportunity for general public and scientists to study the effects of CME on Earth on a much broader scale. From a scientific viewpoint, this event offered a unique opportunity to study the effects of solar storms in our communication systems and satellites. Socially, it increased tourism to regions not traditionally known for their aurora views, with people from around the world trying to capture this rare spectacle of light. In response to this storm, space agencies and meteorological organizations around the globe intensified their efforts to monitor the Sun and its activity, seeking to improve forecasts and alerts for geomagnetic storms. Additionally, the storm reinforced the importance of preparing our electrical grids and communication systems to withstand the impacts of such extreme events. With advancements in observation technologies and the growing popularity of travel to remote locations, more people are getting the chance to witness auroras. Global monitoring programs and mobile apps are also making it easier to predict when and where auroras might appear, bringing this incredible phenomenon closer to everyone. From the aurora borealis in the North forests to the aurora australe in the Antarctic skies, these dances of light are one of nature's most magnificent spectacles. They remind us of the invisible forces constantly operate around us and the beauty that arises when Earth meets space. Auroras are not just visual wonders, they are ambassadors of cosmos. They invite us to explore and understand the world beyond our planet. We hope you've been as marveled by the science and beauty of auroras as we have. If you liked the video, don't forget to subscribe to the channel and activate notifications for more content like this. Share this video with friends and lovers of science and join us in the next exploration of the wonders of our universe.